Properties of linear functions and linear models. A linear function is a function of the form f of x equals mx plus b. The graph of a linear function is a line with slope m and y-intercept b. Its domain is the set of all real numbers. So when we look below here, it says given f of x equaling negative 2/3 x plus 4. Hopefully we remember that y equals mx plus b, and essentially all that's changed here is that I'm calling y f of x instead of y. So nothing else changes from this. So my slope then is going to be the multiplier of my x. And that slope is also called the rate of change. So here, determine the slope and y-intercept. So the slope, and I'm just going to write m equals negative 2/3. Now remember, it's always just the number. It never has the x on it. I can just tell what it is because it's the multiplier of the x. It's the coefficient of the x term. That's another way to say it. And the y-intercept, b. So this right here is my b, which is just the number I'm adding to my variable term. So my b is going to equal 4. So done. There's part A. Now part B says, use the slope and y-intercept to graph the linear function. So the first thing I want to do is graph the point. And from the point, I can use my slope to stay on the line. So that's why I need a point first. Because if I just drew a slope, I could go down 2 over 3, so I'll be over here. And there could be a line. I could do it from here. I can go down 2 over 3, and that could be a line. Okay, so it could be any of those lines if I was just talking about the slope. So that's why I have to start with the point first. So my y-intercept isn't just b, but it's 0, 4. That's what the y-intercept truly is. Now, a lot of books just say, hey, the y-intercept b, even though that's not technically correct. It's really 0b. That's what it should have said, and it didn't, and that's okay. But for us, just realize that we're looking at the point 0.04. Now, if I have the point 0.04 here, 0.4 is going to put me here. And from there, I'm going to go down 2, and so I'm going to go down 2 from there because it's negative. And then to the right, 3, so it's going to put me here. So then my line then will be, that's how we do it from the slope and y-intercept. So I just plot the point first, and then I do rise over run. And since it was negative, I always scoot the negative on top, and then I'm always going right. So if I do have a negative number, that's how I look at these slopes. So I say, hey, this slope is really negative 2 over 3. And I just keep it that way. Now for part C. Okay, part C says, determine the average rate of change. And like I said previously, that's really just my slope. That's what that average rate of change is. So my average rate of change done. Now the last part of this says determine whether the linear function is increasing, decreasing, or constant. So I'm going to go back to the graph. That's how I tell. So when I look at this graph, as I go from left to right, what's happening with that, with those y values? And you can see that they're decreasing. They're getting smaller. Those y values are getting smaller and smaller and smaller and smaller. So that tells you it's decreasing. So there's my answer for this one. So I write decreasing. Done.